Okay, so our this topic is alkyl halides, haloalkanes, and as previously I have shared some of the lectures recording with you that you have to get the familiar with the concept of the functional groups and how you can name the organic compounds. So now we are going towards the alkyl halide or haloalkane discussion, right? So one by one, we will move for the different steps. So the first thing is the alkyl halide is, so as the name state, this is having some of the R group with that, right? And then there is the halide, which is the seventh group on periodic table. And that is commonly named as the halides or the halogen one. So here, this is, they are the number of the applications in your surrounding that you can see that these are materials are made up of the alkyl halides. So one is the PVC pipes, which are the most common one, right? And if you want to define the alkyl halides, so these are the compounds containing a halogen atom and which is the covalent bonded to a sp3 hybridized carbon atom. So sp3 hybridized carbon atom is only in a case when we are talking about the haloalkanes. So just keep in mind. So if that is the haloalkane, so this is sp3, and of course if it is the haloalkene and haloalkyne, so this is the sp2nsp. So you can just refer to that hybridization videos also on my YouTube channel. So where I have shared these lectures also. If someone is interested to go through that or refresh that knowledge, so you can just check these lectures also. So the importance is that the several haloalkanes are important laboratory and industrial solvents. They are the material which are used in the dry cleaning. So they are the building blocks for many organic synthesis. And of course, as we are proceeding in this course, so you will be able to see that how you can use the alkyl halide as your starting material, and then you can convert it into other valuable products. So in today's lecture, we are mainly focusing on the naming and the IUPAC and the common naming of alkyl halides. So we will have some of the practice questions so you can see that how you can name the alkyl halides. So the next is the structure. So the structure is basically, if everyone can see my window, I can otherwise just lower this. Okay. Okay, so let me just off this because otherwise you are not able to see that. Yes. So structure is the general symbol for a haloalkane is Rx. R, as I have told you, this is the alkyl, and X is stands for the halogen. And usually when you are looking at the organic textbooks and when you are looking at the general formulas of the different classes of the compounds, so the X is largely meant to be the F, Cl, bromine, and or iodine, these halogen elements. So there is another halogen element too, but in this group, organic chemistry is basically dealing with the fullerene, chlorine, bromine, or iodine. And mostly we are concentrated on the chlorine, bromine, and iodine because of their reaction dynamics. And I will discuss with that why we are not conducting most of the reactions with the fullerene based in our laboratory, because these are very rapid, very fast. So this is sometimes very harder to control the reaction conditions. So if halogen, so the first thing, one by one, you have to go for this, that how we can name these compounds. But firstly, you have to identify that what is the structure of your alkyl halide. So if a halogen is bonded to a doubly bonded carbon of an alkene, the compound belongs to a class called haloalkenes. If it is bonded to a benzene ring, the compound belongs to a class called haloarenes, which have the general symbol aromatic NX. So here, this is a generic formula of all of these classes, subgroups from the alkyl halides. So a haloalkane is basically, the common name is alkyl halide. So in common name, we end up with the halogen name. But when we are talking about the IUPAC name, so definitely we are treating halo as a substitution, as a prefix. As you have seen that what are the different parts of naming the compounds through the IUPAC rules. And then the alkanes, which is the organic chain or the hydrocarbon chain, which is associated, which is linked with that halogen. So RX is the haloalkane because there the carbon is sp3 hybridized, and this is linked with the maximum hydrogen atoms, and then there is the one hydrogen less which has replaced with the halogen one. Now the next is a haloalkene, an alkenyl or vinylic halide. So vinyl is basically the terminology which we use for the C double bond C functionality, and this is directly linked with the main functional group like the alkyl halide, and there could be the any acid, there could be the alcohol one. So then we name it is the vinyl alcohol or vinylic halide, right? Now the third example is when there is the haloarine, so an aryl halide. So in this, if there is aromatic or benzene-like structure, right? So this is linked with the halogen. So this is the haloarine. So you may be asked the question that where you have given the chemical formula. For example, the CH3 and Cl, or the C1H3Cl. So you should know that what that structures for. So if I gave you the C6H5 and there is a Cl1, so you should be able to draw that structure openly, and you can name it that either that is belong to the haloalkane or the haloarenes one. Now coming to the next is so IUPAC naming of haloalkanes, how we can name that one. So from your previous lecture and the information you may have gained, that one is basically that how we have to select the longest chain in the haloalkanes or whatever the class of the compound is. So the first thing is that the parent chain, which is the longest chain and it has the alkyl group, if there is no other functional group is attached. So currently we are only focusing on the compounds which has the functionality only the halogen one as a substitution, or otherwise they may have the single, double or triple bond, or maybe the aromatic one. So the parent chain is numbered from the direction that gives the first substituent encounter the lowest number, whether it is a halogen or an alkyl group, right? We will practice this one in the next slide. I will show you some of the examples so that will be more clear. So the first thing is this one, that you have to identify the longest chain containing the alkyl group or with the branching one, and you will start numbering from that carbon to assign the lowest number or the high priority to that one. The second one is, if two groups could have the same lowest number from the end of the chain, give the group of lower alphabetical order the lower number. So lower number and lower alphabetical order means the higher priority, which comes first, right? So, and as an example is 2-bromo 4-methyl pentane. So B stands first and it has the lower alphabetical order because A, B, and then we come to the M. So we write the methyl after the bromo one, right? Because then we have to arrange them in alphabetical order. The third point is halogen substituents are indicated by the prefixes fluoro, chloro, bromo, and iodo, and are listed in alphabetical order with other substituents, right? So that we have demonstrated there that either if you have the more than one halogen atom, or maybe you have the substitution in a combination that there is one halogen atom and one is the alkyl substitution. So you will name that in the alphabetical order, and these halogen are used as a prefix. If you just go to that functional group lecture, and you just reconsult that one, so you will be able to see that I have provided the priority order. So just keep in your mind that whenever we are naming the compounds, organic compounds, and this naming is based on the functional group, right? That's why we grouped these under the different classes of the compounds. So the halogen is a class, or the halogen is a functionality which is treated as a prefix. So this, you can see, this is a low priority function. This is not the major functional group. So that's why whenever it comes to the organic compounds, we treat it as a prefix, not as a parent class, not used as a suffix. Like for example, what we do with the carboxylic acids, this is the butanoic acid or propanoic acids. So we use the suffix acid because this is a major class. But in case of the halogen, we treat these as a prefix as one. Now the fourth point is the location of each halogen atom on the parent chain is given by a number preceding the name of the halogen one, right? So we will identify where the halogen group is attached to that carbon, and then we will number that carbon according to the carbon chain, and that number is showing the position of the halogen where it is attached to the carbon number on the parent chain. Fifth point is, in haloalkene, numbering the parent hydrocarbon is determined by the location of the carbon-carbon double bond. So that is another, the important point is that you have to keep it in mind that, for example, if you just compare the alkane versus the alkene one. So in alkane, this is a straight carbon, single bonded carbon chain, and there is the substitution, the functionality, which is the halogen one. But when we get the alkene, so here the other functionality, another functionality is a double bond. So that will get the priority. So you have to start the numbering from the side where the double bond is getting the lowest number. So then you will consider the halogen position, right? So if there is a position where you can assign the halogen and the double bond the lowest number, so that is the more preferred, and that is the most best way and the right way to number the carbon chain. The sixth one is the numbering is done in the direction that gives the carbon atoms of the double bond and substituents the lowest set of numbers, right? So of course, we are writing, as I've told you, that you will go for the double bond and then you will go for the substituents, so which can take all these substituents and the double bond, the major functionality, with the lower number. Now we can do the practice. So you can see the example. So here I will wait for a while that you can just utilizing these rules, and you can just name and share your answer with me on the chat box, so I could just see what you're doing. So just for elaboration, I'm just giving you a little explanation about it, how you are dealing with these structures. So firstly, if you just look at the very first compound, so this is basically the hydrocarbon, and this is the alkane one. There is no double bond, there is no aromatic ring attached, or no other functionality, but there is the bromine which is attached, and there is a branch, there are branches which are attached. So you have to select the longest chain which include the halogen or the substitution which is attached to it. So if you just go for this one, so the longest chain is the 1, 2, 3, 4, 5. I mentioned that from which side you will start the numbering, because if I start numbering from this side, 1, 2, 3, 4, 5. So in that way, I am assigning this carbon the higher number. So I have to go for that side where I can assign the functionality or that halogen carbon the lowest number. So this is the appropriate side that I could start from the left side, and I can number this carbon as a 2. This is 1, 3, 4, 5. And this will be treated as a substitution, and you will mention it also as the prefix with the digit to mention that at which carbon this is attached, right? Now we can just look at the second structure. There are the two functionalities which are attached or which are available on this molecule. So now first thing is that you have to identify which is the major functionality. As I've told you, for the in alkyl halide case, this is a very straightforward thing to keep in your mind, that the halogen always come at the end in the priority order. So if there is a hydroxyl, this is the major functionality. So you will name that compound uh, as an alcohol, right? And there is the Cl which is attached to that side. Now, of course, if that is a major functionality, so we will give the priority to hydroxyl one, and we will start from the numbering to that carbon, which can assign lowest number. I can see think that I should start from this side, but of course that is the wrong approach, because this is the lower priority functional group as compared to the hydroxyl one. Another thing about the cyclic compounds is that unless they are provided with the functionality or the substitutions, so in a cyclic ring, you can start the numbering from any side. This is equivalent one, right? So there is not the longer chain kind of criteria. So of course, this I have to be fixed with the numbering from this side, because there is a hydroxyl, which is a major functional group, and then proceeding to this side. Rather to go from this side, if I go for example, if someone is thinking that they can go for 1 and then 2 and then 3, right? So that is the wrong approach. Why? Because this is the major functionality, right? This is the major functional group. I'm just writing M for major. And this is another substitution which we will treat as a prefix, right? And this is the halogen one. And for major, we are writing it as a suffix, right? So I will go for this one to assign the lowest number. So our effort should be that whenever we are writing or numbering the compound, so we have to select that side. First thing, it has the longest chain of the carbon. Second is where we can assign all of the substitutions and the functionalities, the lower number. Make sense? Now we will move forward for the third example. And here you can see this is again a cyclohexane. And then there is a double bond, right? And there is a bromine. So for this, which side I should start the numbering? So maybe some can think, okay, I should start from 1, 2, 3, 4, 5. Some may think that I should start from this side, 1, 2, 3, 4. So what's wrong with these two is, because whenever we are talking about the doubly bonded carbon, so we always take in account the first position, the first carbon from which that double bond has started, right? So this is the first carbon from which that bond is starting. So now if I go for this one, okay, so this is the 1 and 2. And if I go to this side, so this is the fourth position which I can assign to the bromine. But if I go for 1, 2, 3, 4, 5, so then I'm giving this the higher number, right? So I have to go for the substitution. The lowest number means the highest priority, and to assign the lowest numerical number. So this way is the right way to number that parent chain, and then to name it in as per the IUPAC rule. So I will show you the answer. So let me check that if someone has an answer in the chat box. Let me check. Yeah, you can just write if someone has done any one of these three. If you just can type the name, or you can just unmute yourself and you want to share your answer with me. Hello, any effort? Okay, so maybe that is the some are facing the problem, but I usually do check in a class, but right now we are online, so I just can wait for your answer. But of course, that will make our video more longer. So I can share the answers now. I have assigned some of the tasks at the end, which you have to submit on a Moodle by Friday night, right? So here you can match these answers with what you have done on your notebooks if you have made that effort, that how you can name that one. So the name is the 2-bromo 4-methyl pentane, right? So the longest chain is the 5 carbon. So for this we will use the pent, right? And ene is to mention that this is the alkane one, right? Now for the prefixes, this the second carbon where this is a bromine, so we have to mention the 2. Then for the methyl, which is the CH3 group which is attached there, so this is the 4 position. Now how we will write in a name is, as I have told you, and we have discussed these IUPAC rules, that you will go for the alphabetic order. So we will write firstly the 2-bromo, then 4-methyl pentane. Now coming to the second one is the 2-chloro-cyclohexanol. So when we don't mention the position numerical value, so this is understood that this is at the 1 position. But you may choose it as a, for the more detail of the compounds and more opening up. So 2-chloro-cyclohexane 1-ol or 2-chloro 1-cyclohexanol, so that is all fine, right? But in cyclic structure, we do, and even in alphabetically, what is understood that this is at the first position, we do not write that the 1 position, and we mention the rest of the positions, right? So unless there is another substitution which is at the first position. So the third one is again, this is the 6-membered ring structure, so we will use the hex and cyclo to mention that this is a cyclic structure, this is a closed structure. Then ene, the suffix is for basically this suffix is for mentioning. Let me choose the laser. So this ene is suffix for the alkene, because now this is having the double bonded. Now 4th position carbon is having this bromine, so we will use the 4 and the bromo. So bromo is a prefix we use for writing the alkyl halides. This is not the bromine or the fluorine or the chlorine as a whole. We will write it bromo cyclohexene to show it that this is embedded on a carbon or hydrocarbon chain. So let's move forward. So this is just the table for your more understanding, so you can pick it that if there is a methyl group, that how we will write, what will be the different alkyl groups and their abbreviations you can use. So if this is a straight, this is a butyl. If there is the branch, so you can use isobutyl, right? And if there is the in that way, so this is the methylpropyl, so you can use the secondary butyl, because the carbon which is attached with the other functionality, this is attached with that substitution. So you can just see that one. And isopentyl is basically when this is the 5 carbon structures and they are attached all in the branching form, right? Now the common names. There are some of the common names which are more commonly used in our laboratory, in our daily conversations when we are talking about with the solvents and these one in daily routine, because these are as famous and they are more frequently used, because they have they are accepted, well accepted, even through the IUPAC also. So we usually name these through the common names, but whenever there is the condition and you have to mention internationally and you have to be very specific about the position, so the IUPAC naming give you the exact idea of the structure, what it is. So common name of haloalkanes, and haloalkanes consist of the common name of alkyl group followed by the name of the halide as a separate word. Hence, the name alkyl halide is the general notation how you can name the alkyl halide in a common names. So, for example, if you can just see, this is the simple 1,2 carbon chain, and there is the Cl, which is a chlorine which is attached to this one. So if we name that through the IUPAC naming, so we will write the chloroethene, right? And of course that is at the first position. So we will take that position as a first because there is the double bond which is starting and there is the halogen. So if we'll number this side, because these are only the 2 carbon, so for this doesn't matter. Either we can say this carbon 1 is this carbon 2, unless there is another substitution. So there is a chlorine attached, the halogen, which has specified ourselves that we have to number this from this carbon. We have to start numbering from this one, and this should be the lowest carbon. So 1 and 2, right? So we are not mentioning the chloro 1 number here, right? Okay. So this is the chloroethene vinyl chloride, and this is an announcement that maybe the session just end up. So you can just resume this session by again clicking on the click, right? Because this time is up to the 30 minutes. So then there is the 3-chloropropene, right? This is the allyl chloride. And there are the common names. Compound of the type CHX3 are called haloforms. The common name for CHCl3, for example, is chloroform. So whenever there is a CH and there are the 3 halogen which are attached, so this is called the haloform, right? And the trichlor is basically the ethylene which is having the trihalides attached to that one. So then this is the trichlor. So hydrocarbon in which all hydrogens are replaced by the halogens are commonly called perhaloalkanes or perhaloalkenes. So these are usually used for the dry cleaning, right? And here this is an example of the perhaloalkanes and perhaloalkenes, and you can just see the structure because all of the hydrogen has replaced with the halogen. So that's why these are named as a perchloroethane, perfluoropropane, and perchloroethylene, right? So I have given you all of these type of examples with the chlorine, fluorine, and with the chlorine which is having the carbon double bond carbon chain. Now at the end, there is a task for you. You have to write the IUPAC name and where possible the common name of each compound, and you have to submit that assignment on a Moodle till Friday night, right? And then that will be graded, evaluated, and I will share your score and your answer, and I will be able to give you the feedback. So that's all for today. And if you have a question, so just comment, just write. So I'll be happy to answer you. Thank you.